Hello, pre-calculus. Welcome to section 4.6.1. We are going to do some inverse trig functions today. We're going to start off with sine, and then work our way to cosine and then tangent. So if you look right here, this is our sine function, right? Well, unfortunately, with a sine function or a cosine function, they both are waves. Are these guys, will they have an inverse if we flip it across that line y equals x, our identity function? No, right? Because do they pass the horizontal line test? No, which means when I flip them, they're going to look something like this, right? And it would pass the vertical line test. So what I'm trying to say is their inverses are not going to be functions. So in order for our inverse to be function, we've got to restrict the domain of our sine function. And the way we restrict the sine function is between negative pi over 4 or pi over 2 and positive pi over 2. So between these two angle measures is what we're going to restrict our sine function, so that when we reflect it across that line y equals x, which is something like this, it ends up looking like this. So instead of it repeating and going like this and not being a function, we've got it restricted down between negative pi over 2 and pi over 2. Our sign goes from negative 1 and 1. So my range over here, my domain goes from negative pi over 2 to pi over 2, so my range goes from negative pi over 2 to pi over 2. Here, my range goes from negative 1 to 1. On the inverse, remember we flip the domain and range. So on my inverse, my domain goes from negative 1 to 1. All right, and then if we look at it, this guy down here, if we look at it, this is what we're used to, right? Our unit circle, hopefully you still remember that. We're going to have to throw in a couple of unit circle quizzes throughout the rest of the semester to keep it fresh in your brain, especially when we get to calculus. But when we're looking at the unit circle, if we're looking at between negative pi over 2, that's going to be down here up to pi over 2. So these are the only values that we could have for our inverse function. So if I want to find the sine inverse of 1/2, what I'm asking myself really is, for what angle is my sine value 1/2? All right, so first of all, sine is, we're talking about our y value. So where on my unit circle is my y value 1/2? The first one we run into is right here at pi over 6. And that's the only place on this part of the unit circle where it's going to be positive 1/2. Here at 11 pi over 6, it's also 1/2, but down here, my y value is negative, so my sine down here is going to be negative 1/2. So the sine inverse of 1/2, the angle on this portion of my unit circle, where my y value is 1/2, is going to be at pi over 6. So notice for sine theta, we're plugging in an angle value, and it's spitting back out a number. For the inverse, we're putting in that number value, and it's spitting out an angle measure. So it's the inverse. So you're gonna flip your domain and range. You're gonna flip what you put into and what you get out of it. All right, arc sine looks fancy, but that's just a fancy way of saying sine inverse. So this is sine inverse, is how I'd say this, sine inverse of 1/2. Arc sine of negative square root 2 over 2 is the same thing as saying sine inverse of negative square root 2 over 2. You'll see it either way in your math classes going forward. All right, so we're asking ourselves, for what angle is my sine value negative square root 2 over 2? Is the y value negative square root 2 over 2? And that's going to be down here. So on the unit circle, that's 3 pi over 4. Yep, pi over 4, 2, 3, 4, 3 pi over 4, 3 pi over 4, 5 pi over 4. This is 7 pi over 4 in the unit circle. But 7 pi over 4 is not what we want to call it. We want the coterminal angle that's in between negative pi over 2 and positive pi over 2. So I'm going to go this way, and that'd be negative, same thing as negative pi over 4. But we want this angle measure. We don't want to say 7 pi over 4 because 7 pi over 4 is not in the domain. Our domain is between, not in the range. Our range is between negative pi over 2 and positive pi over 2. All right, and then finally, sine inverse of 3. So where on the unit circle would my y value be 3? Nowhere, right? Is there anywhere on our sine curve where we're going to go up to 3? No. We're stuck between -1 and 1. So if I'm looking for an angle measure where my y value is +3, that doesn't exist. Anything above or below 1 or -1 is not going to exist. All right, I encourage you, I know these are like kind of weird and I'm blowing your mind right now. You kind of have to think outside the box the first couple times you encounter these. And it's going to hurt you if you don't know your unit circle. But go ahead and pause your video and see if you can figure these out and come back when you think you got it. All right, hopefully you tried those. We're looking for arcsine of square root 3 over 2. So I'm looking on my unit circle. Where on my unit circle is the y value square root 3 over 2? That's going to be up here. Because it's positive square root 3, it's going to be up here at pi over 3. All right. Where on my unit circle is my y value going to be 2 pi? Well, 2 pi is 2 times 3.14, blah, 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 so that's 6.28, blah, 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 blah. Is that between -1 and 1? No, 6 is bigger than 1, so this one is not going to exist. And then finally, for C, arcsine -1. Where on my unit circle is my y value -1? My y value is -1 down here at -pi over 2. And there you have it. We'll work on these tomorrow in class. Move on to the next video. It's going to be cosine.